I am starting the recording. As you can see there, I have started the recording. So I think it is a good thing. It's Ubuntu for me to show my gratitude and appreciation for all of you guys for subscribing to my channel. I have achieved my 5-year goal of getting to 1,000 subscribers. So thank you so much for that, ladies and gentlemen. If I had champagnes enough to give all of you hours, but maybe I must show it in the test. So shouldn't kill anyone there in that test. So ladies and gentlemen, so this is what we're doing is normal distribution. I need water. I've been running around with those exam papers. Exam papers are a commodity. There is a problem. I mustn't keep them long on myself. Otherwise, you'll find them on social medias. So now, we are doing normal distribution for resistance of electrical device with a mean of 90 and as a what you call this is a standard deviation of 2 ohms. No? Okay, so you need to understand what is it that they want here. A all normal distribution of continuous variables can be converted to standardized normal distribution, okay, by using standardized normal value z. For example, consider, okay, the value z helps us to determine the area. Ne? So in this example, the value of 92 ohms in figure, which is 1 standard deviation above the mean. So then we have this. So they don't tell us exactly what is it that they are trying to achieve here. But all I can say is, if you're not given the value xi, you can use this method by doing this. Basically, you can be given, you can use this, and you'll find your xi. So this is an addition to our formulas. So the formula sheet you're going to get in a test has this formula here for finding the value of xi. Should it not be provided, this is the formula you can use, right? Then our z it's equals to that's our, it's a scale, something of that nature. They say this is okay, this is a standard the normal value, it's the standardized normal value. So our xi, as you can see there, xi minus your standard your mean value over your standard deviation, it's equals to 92 minus 90 over 2. Your standard deviation is 2. Then the answer is 92 minus 90 over 2. Right. The answer is 1. So what do we do with this one? We want to know we haven't yet been told exactly what to do with this value. However, it's not a problem. We can always we'll figure it out later what to use it, because the exercises start to make sense. So if you look at there, we have 1 here, we have 1 here. Then you need to find the area between that one. So 1 0 is here, 1 0. So these tables are going to be provided in every assessment that you're gonna be taking with me. These tables, you need them because they help you to find what? To find the area. So 1, you see the area there, of 1 is 8413. So the percentage under that area is 8413. So now we say area equals to 0.8413. Then in the scale now, how do you represent that on scale? Let me see, I want to see if this feature does work. Oh yeah, it does work. Oh, no, on my other class it didn't want to work. So this is 90, this is 92. You see that? Then I place a dot there so that I can use it as my reference point as I'm going up. Then I go down like that. Then that's my 2 there. So now the value that we got, which is also converted into percentage form, it will look like 84.13. So if you are asked to find the area here, this is the area at 92, then at times you will be required to find the area above 92, which now when you look at this, it's going to be 100. Okay, this doesn't want to work. I must rather do this. So if you are asked, it depends with the question that we are asked. If you are asked, then you're going to do this, then which is becoming 100 minus 84.3. Then you get, so that's your 15.87 percent. This is what is remaining here, but it will go with how the question is derived. So let's see. Okay, now we are having more, we're having questions that are making more sense now. Okay. Okay, so now I need to make sure that I'm really recording. Don't want mistakes. So we have this one, the mean value of weight of a particular brand of cereal. Okay, so you can just this doesn't want to write. Right, doesn't want to behave. Is fine. We still have a better way to do this. Okay, right. So now we have a mean value of 0.297, right? And then we have a standard deviation of, so you can just write standard deviation there of 0.024. Then you place your dot there and you draw your normal distribution like that. Then they say, assuming normal distribution, find the percent of data that falls below. These are the statements that you must look at when you're doing this. These are the statements that you must look at when you're doing this. So now, lower limit of, you see this 274,297. So you can tell that this is this side at 0.274. So when they say below, so they are referring to this section here, below. So you are looking for the percentage below. All right. Then now we're going to apply our formula again. I want us to take this upward to preserve space. Right. Then we have our formula equals to our xi, that's your xi there, and 0.274 minus 0.297 over 0.024, which is equals to My back is hurting now. Damn it. Ish. How can you sit like this? Sometimes it's best to be in class because you stand the whole day in class. You know that when you're tired, you're tired. Here in the office, it's difficult to really maneuver. So now, my answer is 0.274 minus 0.297. Oh, I nearly forgot. I do not have that digital calculator here in my work computer, because you don't just wake up in the middle of the night and decide to install softwares in your work computer. Here you behave, otherwise you'll be in trouble. So you can only install in your own. I was about to call for that software, but I realized I do not have it here. So you find the value as a negative number. As you can see, it's a negative number, and you need to go look for this value so that you can find, let's say, the area below. So we're looking for the area now, the area below there. So we go to the tables again. We are on the negatives. It's a negative 0. 0.958. Okay, so 0.9, it's this one here. Then 0.9. This one's not the area. You see, now I'm confusing the two. So this one needs to be rounded up to 6. Yes. Then we come here. We go 0.9 and 6. There. Then 1685. Yeah, 1685. Then you write there, it's your area is 1685. So now there's another thing that is very important. So that is the area on that space, it's 16%. So 16% of 0 of what? My pen of 0.274. Okay, I will. Okay, 60% of 0.4724 falls below. Okay, below 60% of, maybe let's say cereals. What is it? What do they call it? Okay, let me rather go for their comment. They have, okay, 60% of the data are less than. Yeah, 60% of the data is less than. Yeah, as I can tell, English is no longer Englishing. So 60% of the data is less than 0.274 kg. 16% of the data. So now, as you can see, that we have achieved our goal. But then, how did I get the Z 0.096? How did I get the negative 0.96 on the table? That's the question that we are asked. All right. If you pay attention here, the Z formula is Z, it's equals to this, right? So the value that we're getting for Z are represented by this, and these are their decimal values. So that will be 3.59, 3.5876, yeah, until. Then we are looking for We're looking for 0.96. See there, 0.96. It's found here. I hope this makes sense. I hope this makes sense. And then you take that area. That area, it's in the form of a percentage. So that area is going to be 0.1685. Right. Okay. Then I would like to move right along. So here we have, using the data from example 5.2, okay, 5.1, or rather say 5.10, the percentage of data that fall above. So now they want to know the percentage of data that falls above. So now, before we even forget our info that we used, so rather we write this. I go here and I make a straight line. All right. And here I write my 0.29. That's my 97. That's my mean, right? And not forgetting my standard deviation of 0.024. Okay, 0.024. Okay, then place a dot there, then follow that dot, and you have your normal distribution curve. Okay, so they want something here which is 0.347, 0.347, and then they're saying above this figure. They want to know the area above, which data falls above, the percentage of data. You see the statement, determine the percentage of data that falls above. So this is what you are looking for. Then you go back to your calculator. You then calculate, that's your Z equals to your XI, it's 0.347 minus 0.297 over, I need to use a straight line, over, never mind the arrow, I didn't plan the arrow, okay, over 0.024. Then the Z is 0.347 minus 0.297 over 0.024. Then your answer is 2.08. You always leave two decimal numbers. Then you go look for it, and it's positive also. You go look for the area. Yeah? So probably we have area 1 and we have area 2. So 1, this is what we're going to find. This is rule number 1. You'll always find, there's something that I might not have shared with you guys. Okay, I'm going to share it now. So usually from here, it's your 0%. There, it's your 100%. That's your area. So now whenever you are calculating going forward. So whatever answer we are going to find here, you will still need to remove the one that we are looking for. But we will get there and explain it again once we are there. So let's go to the tables. We are looking for 2 point, all right, okay, 2.0. So that's 2 on the dot. Where's your 2? There's your 2 here. 2 on the dot, 20 8. I think 1, it's going to be there at the end. So I'll make a straight line with the highlighter to make my life easy. 2, 0, okay? Then I make my straight line. I think the thing is going to play around here. So I need to zoom, yeah, there. So you see here, you do this with a ruler yourselves in a test, then you know. There. So now we've rounded up. We know that it's 9812. 9812. So as I said before, 0.9812. You can see that this, when it's converted into percentage, it's 98.12%. It's not falling above, it's below actually. It's a value that we didn't highlight here. It's this value. Now we are looking for this one. As it was mentioned even before, we are looking for this side here. Therefore, you're going to say, okay, this is area 1, and then so to find a 2, it's equals to total area minus area 1, which is 1 minus 98.12. And you know that this is 100 again, so you can make it to be 100. And this is what you get when you're working with mathematicians. They always understand what you're doing. Hundred minus 98.12 is 1.88. You could use this and say 1 minus 0.98, like that. No crime committed. You could. So now that is your 1.8%. It is also imperative to realize that if we were looking at this from a negative point of view, the answer we were going to get, let's go, negative point of view. So this is when you are confirming your answer to say, hey, but I'm not sure with my answer. The answer is here. Under the negative 0.208, then your answer is there, 0.018. Now answer according to the table. If we're looking at it from the a negative point of view, when you multiply by 100, it gives you that 0.1, that 1 at 1.88. It still gives you, if you look at it from the negative point of view. Okay, so now you write that this is 2 marks. You write this. These other marks I haven't yet thought about them, but that one I know is 2 marks. Right. So now they want to know a large number of tests of line voltage of home residents show a mean of right. So now you can go straight away and draw this, and then you write your 118.5 there, alt. Then a population standard mean of, you write there, that's your data here. You need to always be able to extract the data, guys. Then you put your dot there at the top. Okay. Then, even before you go far, you are able to, that dot will always guide you. Me, I don't want the perfect symbol. I can always say, show this graphically. Then I place 3 marks on this thing. Then they want to know, determine the percentage of data between. Then you come here, 116 and 120. You come and do this, and you do that. And now you see, I want 3 marks here. Yeah, I want 3 marks there. We have 5 already. Aha. Then we do the Z, both sides. So you obviously have to give them names, this thing. And then you have 116 minus 118. My pen is too thick. Let me reduce it. I can see. I like it thicker though. 116 minus 118.5. 120 minus 118.5 over 1.2. 1.2. Then answer. So now 116 minus 118.5. 1.2. The answer is negative 2.08. Very interesting. Then this one, your answer is 120. The answer is 1.25. I want to enlighten you. We have already covered this one. Its area is simple. You go back here. We go back here. The area of, when we said, when you look at it from the negative point of view, we were finding it as 1.88%. You can just somewhere take that one. We've already covered it. And if not mistaken, our tables might be showing it, Steve. There. 1.2 negative 2.08 there. You see this one, this is still there. So actually we have already found it. So the other one is 1.25. So we go to the positive side, 1.2. Once you identify the 1.2, you need to now make it a point that you are able to highlight until there. You can just make a straight line, guys. It's not compulsory to highlight. Make a straight line if you want. It doesn't really, matter much. 1.2, we are going to 1.5. So you shouldn't erase it, of course. I'll put it in an angle so that I don't erase it. You don't want to erase it. If you can't see it, what's the point of what you're doing? 1.2, and then that is 89.44. So that is 89.44. All right, so now the area we are in question starts here. 89.44. It goes all the way here. That is your 0. Probably that's your RRA. It's your maybe area 1. Area 1 equals to hey, when I'm gonna behave better. This thing. So right, A1 is equals to 0. I even forgot that number now because this guy is misbehaving and the fan is very loud. I don't know what's happening. And then where's my hand? Oh, why you look different for my PC? What's wrong with it? Let's go. Hey man, this thing is getting stuck or what? Hey, this thing doesn't want to move, guys. Hey, it's misbehaving now. Him now, Chief. Hi man. We said it's 8944. I'm gonna lose what I'm doing now. 8944. 8944. Hey, now it's too thin. I'm no longer feeling it. 8944. And then that other one is 0.0188. So, but I did mention that from 0 to there to here, that's where you get your 89%. So you need to substitute the two so that you can only get the area there. So that you can get the area there. All right. So now that's going to be area 3 equals to A1 minus A2. Then you have, you can just convert them into percentage form and you get 8944 minus 1.88. Then our answer is 89.44 minus 1.88. Then this becomes 87.56%. Right. Then you do mention the statement, thus 87.56 of the data falls between. All right, moving right along. So now we are given this, the area now. When I give you anything in percentage, that's your area. Area equals to, just convert it immediately, 0.121. Okay, then then you have desired, okay, of the below. It's below, so whatever thing that we are doing, it's below. Let me, the color is visible but it might not be visible in future. Let me just rather stick to my red. Then okay, we have this, we do not have mean, but we have this one, which is 115, and our dot there, and our area below, and we have standard deviation of 120. So now the area below can help us find Z. So we go to our tables looking for Z. So it's 0 because it's below. Immediately your instinct must tell you that I'm going to negatives. So now we're not looking for Z per se. We are looking for that figure, that percentage. Where did it come from? And just like that, there, it comes from there. Then it's at 7 here and 1, negative 1.17. So now this is equals to negative 1.17, right? So now we don't have the mean value. I can just continue here. This xi, which is 115 minus the mean over the 1.2. This goes there, it doubles it up to negative 1.17 times 1.2. Then you write it there as a negative 1.404, which is equals to 115 minus that. So now you need to, if this goes this side, it becomes positive. If this one comes this side, it becomes positive. So now we have this going that side, 115 plus 1.404. Okay, then 1.404 plus 115. Then we have this as a 16 now. 16,404. Then you have 16,404. 16,4 there. There's it, your answer there. Right. And then moving right along to scatter diagram. This is out. This is out. A chair square. Nah, I don't have time for that. Now we are looking at the scatter now. So the first thing first you do whenever you are handling a scatter diagram is I need to read some important factors regarding scatter diagram that you must note down. So now scatter, I need to take a deep breath in. It's a must for me to finish. And the body, it's at 0.0. But I have to finish. The simplest way to determine if a cause and effect relationship exists between two variables is to plot a scatter diagram, cause and effect. You do this and then that happens. Understand? The relationship between automotive speed and gas mileage. The more you accelerate, the more your consumption goes up. The figure shows that as speed increases as the speed increases, gas mileage decreases. Okay, so when they say gas mileage, meaning the distance of your tank reduces. Then the automotive speed is plotted on the x-axis because it's a changing variable, and then we're saying that it is your independent variable. The speed is your independent variable and therefore is plotted on the x. The independent variable is usually controllable. And then the gas mileage is the effect of what you can control, like raising the temperature in order for you to influence how quick your scones can become proper and stuff like that. There's a lot of these examples where you can control either the temperature and you can control the speed, you can control what else? There are a lot of these examples, but we'll see them. And then you are obviously going to draw this. We're going to draw it together, this graph, just now. The y-axis and the dependent or response variables, other examples of relationships are the cutting speed and tool life. So if you have seen a grinder, so the faster you cut, the quicker you'll eat your blade. Then moisture, the moisture content and thread elongation, that I don't know. Temperature and lipstick hardness. So yeah, then striking pressure and electrical current. So that's lightning striking pressure. Temperature and percent of foam in soft drinks. So yield and concentration. That's mostly like of juice. The more you add your juice into your water concentration, yeah. And then breakdowns and equipment age. Okay, there are a few simple steps in constructing a scatter diagram. Okay, and then there is your there is your table, and we have the speed, which is x, and then this as your mileage. You would never find a situation whereby you are given vice versa like this. I doubt. The first one is always X. We don't have time to come up with gimmicks in the test. Anyone who comes with gimmicks, give them like that. So now we're going to draw this plot. So what's my biggest number under speed? It's around about 65. There's around about 40. So something like this will work. Right. And this one is designed to confuse you. Okay. Then we have, they start at 30. Your speed starts at 30. So you can see that you don't need to say 10, 20, 30. You can somehow say 30. And 30, 35, 40, 45, 50, 55, 60, 65. Then temperature goes all the way to, it looks like it's starting around about 18. So it goes all the way to 30, 39, 39 or 38. Okay, we'll assume it's 38 from 18. So this one we can just rather, to be safe, we start at 15. It's counting around about, okay, I want to use method of 3, which is going to be 18. I want to see something quickly before I make you lose. Okay, this one started at 30. You see, it's possible to start at 30. Then I could start at 18. So I'll start at 15. Then I count 3. Okay, 15, 18, 21, 24, 27, 30. And this, if it can increase, I would be very happy. Then it decides to just jump. It's fine. And then I didn't need these other parts. Okay, which is 15, 18, 21, 24, 27, 30, 33, 36, and 39. Right, then we have 30, 35, 40, it's too thick, 30, 35, 40, 45, 50, 55, 60, 65. Right, then done. So now we're taking the data we are plotting. If you want to be happy because you guys will have this advantage, me I don't, I might as well prep myself by doing this. I know I'm going to remove it. You will have an advantage of lines, me I don't have. Okay, this is stagnant. Waste my time. I'll make assumption. That's how we're engineers. Delete. It's fine. So 30 is 38. 30 is 38. You go to 38 somewhere here. You make a big circle, and then 30 again is 35. Then 35 somewhere here is 35. Okay, this is pretty low because this is 36. Then 35, right? Then 35, 30, 40, 33, and then 40, 28, and 45, 32, and then 45, 29, and then 50 to 26, and then 50 to 29, and then 55 to 32, and then 55 to 21, where's my 29? It was here, and 21, and then 60, 22, uh, 6022 again, and then 6518. 6524. We want to find a line that comes here. We want to find the line that comes here. And the use of your calculator, this is where it comes in. If I was at home, I was going to be doing this on my personal computer, then I was going to demo it. Unfortunately, I had to submit exams urgently. I'm here in the office, and the software doesn't have that intelligent, nice, what you call it, that nice software that I have at home. But I've done a video demonstrating, so people shouldn't be wondering how do I do these things fast. Okay, I've copied so that I want to paste it somewhere here. Okay, I don't need to paste it because it's already done. So we are trying to put, okay, but that one is a little bit bigger. I might as well delete this. I'm going to say this. If you don't have a programmable calculator, you might consider doing the old method. Will give you marks, but it will take you forever. So if there is a shortcut on something, you must climb that wagon of shortcut. Do not stay behind and you say we're disadvantaging your education. No. If you're looking at this formula, if we are looking at this formula, the formula for M, because this is for, we are looking for, actually, this is your formula for straight line, right? Then you are looking now for M and then for A. So these are the formulas for the two. And then, but to order to get this is XY. You need to come into to the table. Agree of XY, your speed and your mileage. You are required to create a table for XY and multiply 30 by 38. And then also you need to find this, the sum of X, the sum of Y, and the N value, and then the X squared. You must look for all those things one by one by doing this X and X squared. And if you are doing regression, you might need even the thing there. So you can tell that this is a lot of work. This is a lot of work, but on your calculator, it is doable. On your calculator, it is doable to do this. So first thing first, we are going to look for, on the formula for M, is the sum of XY. So now I will say this aloud, so that people can hear me carefully. Click on Shift and of your calculator, click on 9 to clear the memory, and then you say 3 to clear all the memory so that your calculator has been resetted. Then we do not have any frequency. Therefore, we're going to click on the mode, and then we go to click on the state, which is 2. Then the variable that we want to click are the X and Y, which we're going to select number 2. And then as you can see, you have X and Y. Then now you need to capture the entire data all the way to 16. So 30 equals to 30, 35 equals to 35, 40, 40, 45, 45, 50, 50, 55, 55, 60, 60. So you do this clicking the equal sign. 65 equal sign, 65 equal sign. Then you use your your arrows on your calculator to go on the top so that you can be able to see. Hey, I'm gonna attempt this thing, Len. I'm not comfortable with it, but I'm gonna attempt either way. Allow. I've opened you. Sure. You are drunk. That. Share. Okay, this basically requires me to come out of the session and come back again. All right, let me leave. Don't go. The class is still being recorded. Let's see, share camera. No, integrated webcam. I did disabled. This thing. So there, yeah. Guys, you'll figure it out. Didn't I share it? Oh yeah. Oh, it's visible. What else do you want? You guys. All right. So now, but my problem is my data need to be on the other side. All right. Yeah, there. Okay. So I've done the X. Now I'm doing the Y. So it's going to be 13, 38, 35, 35, 30, 33, 28, 32, 29, 26, 26, 29, 32, 21, 22, 22, 18, and 24. All right. So now we need to find data. You say AC. We need to find data, let's say for your Y. You say shift stat sum 3, then you look for your Y. That's your Y. So let's say you want to get the Y, that's 4. And then the answer is 454. The answer is 454, right? Then you want to write that one down. Then you're looking for another one. That is your sum again. We're looking for the x, sum of x, which is 2, 760 there. Then, so all of them, including even the regression itself, standard deviation, you can find it. The regression, you can find it there. Let's say you needed what? The standard deviation, that is number 4. That's your standard deviation there. Okay, so now you can see how we get the data. So we are not going to be asking each other funny questions. So I've demonstrated that for you guys, even during class. So now I need to share my screen to demonstrate that this thing I've been doing it. Eh? I want a touch screen. That's the touch here. Perfect. Okay, and then I bring back this side. Right. maximum screen. All right. So what are we looking for? We are looking for, okay. So now the value of xy 3 with xy is number 5, which is 20 685. Then minus open bracket there, the what you call it, 760 that we found there, 760 multiplied by the 454 that we found. I hope you still remember that. And then everything else must be in brackets. You can just put brackets here, and then you say over. Then I believe n is 4, and n is 16. So it does give you everything that you are looking for. Then the n is 16 there. Then you close bracket. Then you go under there, your x squared. You go back to your sum. It's the first one, which is 3, 8, 200, then minus open bracket x squared, which is no x, which is 760 squared like this over 16 close bracket. Yeah. Then you obviously, if you're not sure about something that you are doing, you go back and just confirm it, like your 2x, your x, sum of x. So now, okay, then my m now it's equals to the best thing here to do is to write down all the values that you're gonna need. So we have m, y, and x, m. That's not a problem. All the rest of this data is not a problem. However, the best thing to approach this is to add everything, because your calculator, as you can see, it's no longer acting up the same. I will need to go back to memory lane to use it as it is. Otherwise, I'll have to clear. But I don't want to clear. I want us to continue. So now I'm going to deal with everything that is here. So 2685, then 760 multiplied by 45, like that. Then I'm getting this, divided by 16. Then I'm getting this 21565. I'm doing this approach because of the calculator. It has turned to that method whereby it doesn't allow me to just punch it in at the same time. 760 squared, I have this, divide by 16. Then I have that. So now 1611 like that, it's equals to. So now I believe I can be able to punch it out straight. Put bracket divide by bracket, okay, and then it's minus minus, so far minus minus, yeah, minus minus. So now we do 2068 5 minus, oh okay, minus 21 565 divide by 38200 minus 36100. The answer is negative 419. Negative 419. Right. So we move to the second formula. There's it. It says sum of y divided by n. So your y is 454 divided by 16. Yeah, that's my 16 minus minus minus, so make it a plus 0.419. then that's your x, which is 760 divided by 16. Then your a, which is a, it's equals to, now it's equals to, so now if I do this in brackets, I will win 454 divided by 16. I move, I say plus, open bracket, 0.419 multiplied by, and then open bracket again, 760 divided by 16, bracket. Hey, brackets are very important here. Then I'm getting a 48. 48. I don't believe this 48. I need to confirm it. Where is it? Oh, this thing, they didn't confirm it. Really? Jesus. Okay. It's 48, man. I know. But it doesn't feel right. You will sum it up nicely with your fancy calculators. Mine at this point is not, make sure, which is 48. Guys, what's the right answer? You can just shout it out because I feel like something is wrong here. 2, 8. 2, 8. Or else let me just get my calculator. Yeah, I am back now. 45, 454. Do I have 454? Yeah, 454 over 16 plus 0.419 multiplied by 760 divided by 16. Okay, I'm getting the same answer. All right. So now we have y, it's equals to a, which is 48.28. But the formula, it's a plus, but m is negative, so 0.419 x. So now you want to identify your x, your y here at the top here. So my rule that I use, I would take the first value here. I would take the first value here as my x, and then which is 30, there. Then so x is 30. So then we're looking for y. When x is 30, we can change there, equals to 48 minus 0.419 times 30. Then y is 35. Y is 35.7. Then with a different color, which is, we can just say 36. With a different color, you come here, your ID, your 36 there. Okay, now we're looking for y here again at 65. Because x is given. So y again at 65. Y equals to 48.28 minus 0.41965. 48.28 minus, then you're getting around about y is equals to 21. 21. So you go to your 21. So there's your 21 around about there. But obviously it must coincide there. It must coincide there. Then on your graph, it will, on your graph paper, and you're gonna have something of that nature. You're gonna have something of that nature. All right, apologies for that. I think I kicked my a docking station. So it's a very small device that connects all your cabling and stuff like that. So I kicked it by mistake here and it disconnected me, but I am back. So then, if I made a mistake, guys, you can always read, man. Corey, what is what? You can always read, and you help us to find the right ways to do things. And then, book problems now. Okay, if you do the regression, that's the formula for regression. I time and energy I don't have. So firstly, I want to give you a homework now. We just did this one. I get. We just did this. You still remember it. Homework. Exercise number 51. It's your homework. And then exercise 46, 47, 48. No, except 48. 48, I'll do it with you. But exercise 46 and 47, those are your homeworks. So I'll erase this. And 46, 47, those are your homework. Those are your homework. So now, when we are doing problems, you see here, they are saying to you that we have 125 readings and we are looking for interval. Okay, five five rows of readings or 5 columns of readings, and we're looking for 125. That's your observation, and you have they say just plot a frequency diagram. It doesn't work like that. I won't give you such a similar question and say plot it. No, I'll say find the. I'll say to you find the range. Yeah? Then you look for the range. So now and I'll give you this table here. I'll give you these tables there. So, and you know the range is this minus that. So I'm not going to draw the histogram, but I'm going to quickly. Range R equals to R high minus R low, then 2.28 minus 1.72. 2.28 minus 1.72. That is your equals to 0.72. 5, 6. Okay, then we move right along to the second one, which is the interval. These are the things that you're addressing there. The interval followed by the number of cells. Interval, you have your I is equals to I1 plus 3.322 log n, which is this is R. This is R, guys, which is 0.56, and then 1 plus 3.322 log 125, which becomes my answer 1 plus 3.322 log 125, close bracket. Answer is 0.07. 0.07. You do not round up anything. Then the number of cell, number of H is R over I, which is equals to 0.56 over 0.07, which is equals to 0.56 over my answer, and I'm having 7.9, which is equivalent to 8. So we're going to have 8 bars, 8 bars, right? Then now, second thing that you need to do is to go to that rule that I shared last time. The rule says that if this is my x1, this is my midpoint, and then this is my x2, we know that this is my midpoint 2, MP M1, M2, midpoint 1, midpoint 2. The distance of the interval is from there to there. That's your interval. But at the same time, we understand now that the very same distance is required between two intervals. So in 2, x1 and x2 is the same I, right? So now when we are looking for this for M1, we are going to say x1 plus I, but we want I halfway. We want I halfway. Then if I am to erase, and so now you see this is I all the way, but halfway to it. Then our formula then becomes M, which is M1, MP1 is equals to X, we can just say X1 plus half of the interval, which is 1.72 plus 0.07 over 2, which gives you or gives us 172, yeah, 1.72 plus 0.07, that 2. Then we are left with, okay, we're taking two decimal numbers, we are left with 1.75. 1.75. That's our first midpoint. So now we go to the tables. We create the table. It's going to consist of okay, then take the table there. There's some certain things are better with the mouse, man. And certain are better with this thing, but it's fine. So now 1 point. No, I said that this blue is going to give me issues. It's not visible to my liking. So here it's your mid points. And then this is your frequency. This is your cell boundaries. Then 1.75. So now we have upper boundary and lower boundary. So now the upper boundaries are upper boundaries. No, they are called lower boundaries. Lower boundaries are found this side. Upper boundaries are found that side. They kind of give you some sort of a bracket. This thing is going to be between A and B. Then whatever that is inside, that's what we are measuring. Okay, so now UB, we've derived that. We can find UB, which is upper boundary, by saying midpoint plus, because we want to move from midpoint here to here. So we can easily say midpoint, so upper boundary is equals to midpoint 1 plus half of the interval. You're going to get what you're looking for. Then we delete these other things that we don't need here. Then, which is 1.75 plus half of our interval, which is now 1.75. You erase in your calculator that previous answer. You don't use it because we do not consider further than 2 decimal numbers. We ignore. That's the rule that they're using. So you're going to find 1.78. They say 885. No, you ignore that. Then 1.78. So 5 is in the middle, as you can see. So there's something happening here, but it's fine. Then the lower boundary is this one. The lower boundary is 172. And then when you look at where's 75 centered from 2, it's well in the center there, 75 and 8. 5, it's in the center. So now, however, this one, which is now you want to find, actually not, you want to find lower boundary 2, it's equals to your xi plus interval. Then you're going to find it as 1.72 plus 0.07. And it's going to lead you to 1.79. 1.79. You grab your calculator, 1.79 plus 0.07. Then you're going to get 1.86. Then you just click you just say again plus 0.07. You're gonna get 1.93. Enter, you're gonna get 2. Enter, you're gonna get 2.07. 1, 2, 3, 4, 5, 6. We're still outstanding some values. Then enter, you're gonna get 2.14. Enter for the last time, it's gonna land at 2.1. You can still do this and add the same here, but you need to understand this. You saw, then this is 1.85. You can do this. It's fairly allowed. 1.92, 1.99, 206, and then here 213. Wait. So ugly, the 213, but it's fine. Yeah, we have to finish. Then this one, 213 plus 20. Start 206 plus 107. Okay. I have 13 plus 207. I have 13. Where is it leading me? 13. Okay, 206 there, then 13. Then this one. Why is it 2? Okay, 2.13 plus 107. It says 2.2. I don't understand why 2.2. It's supposed to be one less. Let me go check. Something 1.79 plus 0.007 equals to that, plus 0.07 equals to this, 193 equals to 2, equals to 207, equals to 214, which is 13 that side, equals to 221. Okay, then now here 178. I think I have no choice but to make sure that this thing makes sense. Okay, 185 there plus 007, that's 192, plus 199 plus 206, yes, plus 213 plus, oh, this is 220. Oh, 227, 2.27. Yeah, slight mistake. Yeah, it's possible. Plus 0.75 plus okay, 0.007, like that. Okay, this is now we're getting center of 182 plus 0.07, 189, 189 plus 196 plus 203 plus 2.1 plus 217 plus 224. Okay, then now we check on the frequencies the same way we were doing it, where your frequencies are quite far from me. Copy, oh no, paste them close by and zoom. Zoom. So I am not going to finish this because of time. So now, as you can see, you just put a highlighter here. This is your starting, then this is your ending, 78. You just highlight there. Then you sum everything between there. That's your 1 plus 1 plus 3 plus 1 plus 1, which is 7. And this is how you get your 7. Then this one here, 85, 79 to 85. The 79 to 85. You go to 85, you highlight 85 like that. Then you do the same. You're going to say 1 plus 3 plus 3 plus 2 plus 3 plus 1. Then you're getting it as a 13. So you need to finish up this by yourself and draw the graph, then send me the for what you call it, for consultation. You send me and then I'll tell you whether you are on the right track or not. So now we have this other one that is very important. I needed to skip to it. Then this one is, we have interval of 0.3, and we need to determine the average. So there's a formula for average. Sum of fx, that's your xi and f. You need to be able to find it. So to find that average, obviously you do the same thing on your calculator. But first, I want to show you step by step on how to set up the calculator whenever you have the frequency. So I'm going to turn on the camera for the frequency. All right. So now I'm unable to flip this, which is not a problem. You know your calculators. Then you go to shift mode. Then after that you go down to stat. I went down, then I've stat, then I click 3. Then it says, do you want to turn on the frequency? Yes, I want to turn on the frequency. Then when you say mode, then you say stat, then you say the first one, then you will have X, and you will have the frequency. You see that? So now you capture. Okay, I'm unable to capture properly. I might as well stop sharing. Go back to the screen, entire screen, which one? This one, and share. So I'm going back there. Then now I'm patching 3.5, 3.8, 4.1, 4.4, 4.7, and 5. Then what are your frequencies? Your frequencies are 6, 9, 18, 14, 13, 5, right? Then now you want to confirm. They said the frequencies are 65. Let's prove that by going to stat, and then your variable, your n. Your n indeed is 65. So we know that if you look at this, we have 65 here. Then actually it's this one here. The formula, this one, that's a 65 under there. Then you want the sum of these two. Then the sum you look for, I will tell you now, you look for under sum 3, you look for just x, sum of x. It is incorporated with the frequency. So you just take the sum of x, and you'll find it to be 276.7 equals 2. So you can just divide by 65 that value, and you're gonna get 4.25. Then they say find the standard deviation. So you look for the formula for standard deviation. The formula for standard deviation is this one with frequency. It's this one. You are going to look for the values that we're looking for, and you're then going to punch them, and you'll see that you will be able to get the right answer. But my main interest now is determine the median position and the median. So the median position, there's a formula for the median position. I don't have it here for some reason. So for the median position is 65. It's 65 divided by 2. So you will find it as 65 divided by 2 is 32.5. 32.5. Then, so 32.5, then we can see that 1, 2, 3, and then 1, 2, 3. It's found in between here. Ne? But what will assist us? We'll be assisted by doing the accumulative frequency. Then we'll know where we need to stand. So when you are doing the, okay, we found the position, then LM, the lower boundary, the frequency, the interval, the CM. Now the CM is 1, it's not 1, it's 6. 6 plus 9, it's 15. So if you add 18, you're going to get 33. So you shouldn't go above the median value. So you know that what we are looking for is here. What we are looking for is there. Then, okay, so the CFM is equals to 15, which we take the value before. Ne? When you go to your booklet, in your book, you will see this. They explain it thoroughly. That it's a one before, and then the frequency is 18. The frequency is 18. Then the lower value is 4 there. So now what do you have? It's 4 plus that one, it's 32.5. This is the 32.5 minus 15 over 18. Multiply by, do not forget the I, 0.3, which is equals to 4 plus, I need to clear my calculator showing that funny way, right? 4 plus 32.5 minus 15 over 18. Then you close it and then you multiply by 0.3. And your answer is your median. Okay, all right. Okay, 4, 18, yeah, that's fine. 4.29. It's your median. Okay, and then I want to, this is your homework. Guys, take my homework serious. You know when I say something is your homework, what do I mean? And then the first section is your homework. Then now, and the second section here, which is 46 and 47, I'm only going to do this one. This one is very interesting. We are given we're given 12.5%, and right, this is how you're gonna see it. Guys, we are online, we are in the comfort of your homes or rest, so let's not rush each other. I know that time is against me. Let's not rush each other. You are already able to go and grab some lunch. Me, I can't. I'm stuck in the office. So please, relax, I'm gonna finish. I'd rather be thorough than to let you to be confused. So now we have the 12%. It's what they're planning to rework. 12% of rework rate. It is said that in a precision grinding of complicated part, it is more economical to rework the part than to scrap it. Therefore, it is decided to establish the rework percentage at 12.5%. So that means that our, all right, if you have another class right now, let's rather say this. This is recorded. Let me rather take my time with this and continue with the recording. so that you can watch the recording. How's that? Because Friday, I'm not seeing you guys. I am seeing my other group. As you know, I've told you that I have 2 groups. So the recording is going to be there. I'm going to publish it. Definitely. The content we've covered today, yes. And especially, that's why I say take note of my homeworks. Histogram is there. And take note of my homeworks. That's all I could say for now. Take note of my homeworks. Make it a point you do my homework, otherwise you'll see how I function. I don't want to reveal too much. Take note of my homeworks. I'm dead serious about it. Do my homework. If my homework confuses you, consult, and you'll thank me next week. So now I'll continue in peace, and then you guys will attend your class. Me, I don't mind continuing. I want to make sure that I cover. So now then I can lower down my speed. Let's say now this implies that 100 minus 12.5. So this is the rate at which you are rejecting. Then we want to minus from 100. We want to minus from 100. 100 minus 12. 100 minus 12.5. It's equals to 87. So this 87.5, it's actually 87% of good products, which is here. So it's 80% of good products. Good. And then the 12, it's bad, meaning rework. Then the upper limit now, they have an upper limit there. They have a standard deviation of 0.01 and an upper specification limit of, so that limit the specification. So if you go above your specification, it's like going below your specification. So you're gonna obviously produce a rework. If you go above the specification, you are producing a rework of 25.38. That's your XI. But we want to deal now with this. We want to deal with your 12 your 12.5. What are we looking for? Okay, we got determine the process center, meaning that we do not have this, we don't have the mean. So you cannot find the mean with this side. You must find the mean with overall percentage of 87.5. 87.5. This is where you're gonna determine your mean. Okay, so we're gonna use 87.5. So 87.5 divided, we are getting it as area 1 is equals to 0.875. Okay, so this question, it's very interesting and tricky. You are going to look for 875. You will notice something very critical around about the figures of 8, 8 there, 8-7 here, 8-7-4-5 here, where our numbers going, they're going this direction. So I have noticed that my value is around about here. My value is around about there. So now, if my value is around about here, what does this mean? It means that I can simply take for this, which is 1.1, 5, and 6. 1.1, 5, and 6. So I have two z's. I don't have my center z that is proper. So now we want to take average of the two. 1.15 plus 1.16 over 2 is equals to. So my z is going to be the division of the 2. The 1.5 plus the 1.6 over my 2. So then my value that I need is 1.55. 1.155. This is the value that we are looking for. So that's your Z. Then you come here. Z, which is 1.155. It's equals to your XI is 25.38 minus this value over your 0.01. Okay, then this goes there. This goes there. And it becomes times 0.01 times 0.01. I need to confirm my standard deviation again. Okay, 0.01. Okay, it's fine. Then there, that's my Z. Okay, it's fine. So my Z is 1.155 times 0.01. Then I'm getting my value as, okay, and then I need to shift them around. This goes that side, this one goes this side. So my U is equals to 25.38 minus 0.115, which is equals to 25.38 minus my answer, and my value is 25.37. But this needs to be, I need to check it out. I might be doing a mistake. I need to make sure I teach the correct ways. Okay. Question 48. $25.37 is our answer. Yes. And the answer is correct. Right, I was not sure. I've been practicing a lot of things. So now, because we have other people who left, please take note. My homeworks are very critical. So now we can go back and play with this one and finish up this one. Okay. So I think that's the only one. Oh, I can also let me rather finish up this one. Yeah, because we are now all alone and yeah, the time is open. So now from here, I have 86 to 92. 86 to 92, which is here, it's 87 to 92. There's my 92 there. Then I combine 6 plus 1 plus 3 plus 10 plus 5 plus 7, which becomes 32. Okay, then from here we are going to 99. 99 somewhere here, 99 there. So now we have 4 plus 4 plus 11 plus 2 plus 8 plus 2 plus 4 with 35. Then from there we have 206. We have 206 there, which is 11 plus 4 plus 3 plus 1 plus 5 plus 4, which is 28. From there we have till 13 and then 20, 27. Yeah, 13, which is 12 there, and then 20 there. So all the way to 13, we have 1 plus 1 plus 3 plus 1, which is 6. Then from there, we have, I think it's 3, and then we have 1. So all this combined must give you a 125. So we have 7 plus 13 plus 32 plus 35 plus 28 plus 6 plus 3 plus 1. All combined in my calculator, I'm getting a 125. So now with those calculations, you can easily have a nice graph consisting of the midpoint. And before you label it, let me rather do this. Before you label your graph, it's just best to do this. I want to know which one goes. F frequencies, the ones that are going up, they go to until 35. Okay. This one, they just need to be a number, that is good. Okay. Then I'm going to use 5s. 5, 10, 15, 20, 25. Grab this, take it down, and extend it here. Okay. 25, 30, 35, 40. So 5, 10, 15, 20, 25, 30, 35, 40. Okay. Then these ones must be 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So that is 7. Seven is around about here. Aye. What are you doing now? Allow me to write the way I want. Don't place things. 7. Okay, and then from 7 we're going to 13. Obviously, my stuff to write are not as perfect as when you're using a ruler during a test. Okay, then that's your 13 there. Then from there you're going to 32, around about here. Okay, then from 32 you're going to 35. Okay, then from 35, you go to 28. This is 25, that is 28 somewhere here. Then from there, you are going to 6. From 6, you are going to 3. And then from there, 1. And then that's you have your graph. It's not well centered, but yeah, there's your graph. So that part of the graph, it's done. At least it's in the recording. Then I'm gonna this is still well in your mind. Still remember we added this in the calculator, the 36 and the 15. It's x and y, and then after that you go look for this. You go look for this, and then you look for this, of course, these two, in fact. Then you go look for these two. Then done. I doubt I'll ask for regression. I'm not sure about the regression. I am not sure about the regression. So now that's your scat done. Explained it. And then here we have a homework. It's very critical. I'd rather maybe say this one. I remove it as from a homework side. We do it together. Although this one is also straightforward. If you may remember, we were working with 1.5. We are giving it as a 1.5%. That's your area. So then we want things that are below. So immediately when you are going for below, we have this. Then you have possibly you do not have the center, the mean. So you are looking for something here, and that's your 0.6. No, 0.567. They say below. Then I can somehow take these things up and like down. Right, let's go up and like down. Up, yeah. Then 5, 6, 7. Then your dot there. Follow your dot again. Follow your dot again. Then we have this. Then we're given that this is what? 0. 1.5% and convert that 1.5 divided by 100, it's actually 0.015. You see that? So that's your area that you're going to look for in the table. And with that, it's going to determine the value of Z. And you know your XI, your XI is 0.567 minus that over what's your that's your standard deviation, which is 0.018. Then we're going to multiply it by the value that we're going to find there. So we go to our graphs. We are looking for 0.015. We're looking for 0.015. It's on the negative side because it's a little number, and then it's 0.0. You see here, there's your value there, 0.015, and then we have a 7 there, and we have a 2,1 here. So negative 217. Okay, negative 217. Yeah, the auto thing is doing its funny things here. 217. Okay, then that negative 2.17 we multiply by 0.18 of our standard deviation, and we find it like this, and it's going to give us then we need to swap around because it's negative. Swap around, we're going to have this is equals to 0.567. I think this is going to be a plus 0.3, no, 0.039. Okay, then plus 0.567. Then our mean is 0.606, and obviously you can see where it's positioned above, which is good. Then okay, for this one here, we did cover the average, we did cover the standard deviation. Standard deviation I said is straightforward, and then the skewness. Okay, when you're looking for the skewness, it's the only one that is forcing you. Before people say we didn't do skewness, let me do it quickly. So I'd like to believe it's 425, something like that. So the skewness, what you are looking for is, unfortunately, there's no escape for the skewness. Well, frequency, delete here. You stick to this formula, looking for skewness. Its original formula is this one here. So we are looking for these values here. We're looking for the standard deviation. We are looking for fxi minus that what you call the x bar. So now I'll just do 1 so that you can be able to follow. Your f is 6 over your x is 3.5, then that's your 4.253 there. Then you find the sum. You see that, and you continue 9, 3.8 minus 4.25, and you find what? you find the sum there. You find the values. You find them until all the way down, and then after that you sum them up. Once you sum them up, it means that this whole here, this whole thing here at the top, it just needs you to divide it by n. Once you divide it by n and you divide it by S3, you should be able to find your answer. You should be able to find your answer. Ladies and gentlemen, I would like you to make it a point that you go to an extent at which you solve these things, yeah? Sitting comfortable at home as preparation for your test. And me, my job is to thank you for that effort. And you are allowed to then consult on how did I find, like, if whether you are right or wrong. You are allowed to consult. But I feel like standard deviation, there's no way you can be wrong for standard deviation. Let me prove you, because the calculator does give you standard deviation. The only thing that doesn't give you is the I want to turn on the frequency first, then I go to the stat, then I go to this. Okay, then we have 3.5, 3.8, 4.1, 4.4, 4.7, 5. Okay. My inspiration for my test won't be drawn too far from the source. Keep that in mind. And that's why I'm emphasizing that do my homeworks, and me, I'll find a way to thank those who did the homework. So let's I'm going to look for the standard deviation in case. Yes, it's number 4. Standard deviation 0421. The standard deviation is 0421. So now you can see that some values you can able to generate yourself and prove yourself whether you are wrong or right. We can't honestly do that part, whereas your calculator can guide you. 421, that's your standard deviation. Then you use that standard deviation now here, 0.421 sum of the 3. Then that value that you would have generated here, the total sum here, you're going to bring it here. The sum, you're going to bring it here. It's straightforward. If you're struggling with the X bar, shift 1, variable 4, and then X bar is the 2. The X bar is 4.256. It's there. So there's nothing that we should be arguing about this. This is straightforward. If it's there in the test, give me my 100, guys. I did mention that complete these things. I'm gonna choose around them, and I'm gonna try to be 50 and below in the marks. 50 and below. Histogram is there. Histogram is there. Although this part is still this is still histogram. This is still histogram. So both this one and that one, they are histogram. Understand them, how I maneuvered them. Understand them. And this, understand it as homework. And this, I will teach you what I mean when I say the apple doesn't fall far from the tree. I do not have any question bank, and I am the question bank, and this book is my question bank. So it's in the recording. Ladies and gentlemen, thank you so much. Do we have any further questions? Okay. In the absence of any questions, I will see you next week, Monday, from 3 to 5. That's the slot that we are allocated for. I'm going to book the venue. I'm going to book for the invigilators. And then we take it from there. I'm going to publish your assignment after you've written the test. I do not want you to be stressing about that assignment. Let's just give me good marks here. We'll do the assignment later. Okay, ladies and gentlemen, thank you so much. See you next week and all the best. Bye bye.